All right, so we are starting into solving for equations, solving for an unknown, typically what you would think of algebra, a lot of things, solving for x or solving for a number. In the previous section, we talked about some of these properties, and I noted these two, the additive inverse, multiplicative inverse. So basically, we can add opposites to get it to equal 0, or we can multiply or divide a number to get it to equal 1. So there's always a number we can multiply or divide to get something to equal 1, or something we can add or subtract from something to get it to equal 0. That is basically what we are going to use over and over again when solving for equations. So I'm going to be referring to those a lot in this section in helping you understand how to solve for a variable. All right, so the goal of algebra is to get the variable or the term by itself, or to make the coefficient of the variable a positive 1. So if I had a negative x, the goal would be somehow to make that be a positive x, because these would be 1. If I had a 2x, I would want to know how to make that a 1x. Okay, so whenever I say get the variable by itself, it means make the coefficient a positive 1. And we are going to be doing that mathematically over and over and over again. You're going to hate it or you'll like it, but hopefully this explanation helps. So inverse operations was what we just talked about, those notes from chapter 2, what we worked about, but here's a couple examples. So this is an example of an inverse operation of addition. If I have 4, I can subtract 4, makes it equal 0. If I have a negative 3/4 and I add that, or add the opposite, it equals 0 as well. So it's numbers that we can add or subtract to another number to make it equal 0. So if I had a negative 2, to make that equal 0, I would add 2. All right, if I had a negative or a positive 2.75, I would subtract a 2.75, and that would be 0. So you're just adding or subtracting the opposite to it, or you're adding the opposite. The multiplication example, what we have here is that there's always a number that I can multiply by another number to get it to equal 1. All right, so if I have a 4 and I multiply that by what is known as the reciprocal, we've talked about reciprocal before. So the reciprocal of 4 is 1 over 4, because 4 over 1 is the fraction version of that. The reciprocal of 3/4 is 4/3. We multiply those together and we get 1. Another way you can think about it is if I divide by itself, I will also get 1. So if I had the number 5, to make that mathematically equal 1, I would divide it by 5, and 5 divided by 5 is 1. So if we can get that concept down, the way we break this section down, it should make it make sense. I talk about this, and I'm going to show you a way, because I think it makes life easier. But if you multiply a fraction by its denominator, you get the numerator by itself. This is what I mean by that. So if I have a 5 over 6, if I multiply this by 6, that's going to equal just 5, right? Because 5 over 6 times 6 over 1, which is my 6, these would divide out, giving me 5 when I multiply across 5 over 1, which just equals 5. All right, so keep that in mind. Sometimes what we are going to explain as single-step problems could be a multi-step problem, and you'll see this in an example. But again, if I multiply a fraction by the denominator, so for another example, if I have 3/4 and I multiply it by the denominator, which in this case will be 4, it's just going to equal the numerator as a whole number. All right. So another good little math trick to know that's going to make our life easier as we go through these problems. Okay, so when I say one side or the other side of the equation, what I am referring to, and now I'm getting into this part, is the equal sign. So the equal sign basically means whatever's on one side of the equation is the same as the other side of the equation. Obviously, it might look different because 4 times 1/4 doesn't look like 1, but it does equal 1. All right, so when we talk about balancing equations or solving for an x, I like to think of it as a teeter-totter, because whatever you do to one side of the equation you must do to the other side as well. So the exact same operation. So think of it as kind of like a teeter-totter. So if I add a box to this side, what's going to happen is this side is going to go down. For me to keep it balanced, I would have to add a box to this side. If I had 2 boxes to this side, the only way to keep it balanced, because then it would go down this way, would be to add 2 boxes to this side. All right, but if I take a box away, all right, so let's say I'm getting rid of a box, well, what would I have to do to keep it balanced? I'd have to get rid of a box over here. All right, so whenever we are using math to manipulate a problem to solve for an unknown, we have to make sure we keep the operation balanced. And when I say whatever you do on one side, you have to do on the other side, I'm talking about of the equal sign. So this is our teeter-totter. This is telling us that x minus 5 is the same as 27. Now, I've mentioned before, the goal of algebra is to get the variable by itself to equal a positive 1. In this case, I want you to see this as terms. So look at our left side, look at our right side. All right, our left side contains 2 terms, a 1x and a negative 5. Our right side contains a positive 27. So our goal is to get this 1x by itself alone. So how do I do that? Well, I work on balancing or using inverse operations to get that by itself. In this example, you can see the negative 5. So I'm going to use the inverse operation of addition to make that equal 0, because x with nothing is by itself. So to get a negative 5 to become 0, I add 5. However, I have to add 5 to the other side, going back to this teeter-totter example, to keep it balanced. So then when we do negative 5 minus 5 equals 0, we just are left with x on this side, and then we have the 27 plus 5, which equals 32. So if I'm going to be kind of showing my work how I would do this, all right, so again, I tried to show it with the computer, but x minus 5 equals 27. Look for those opposites, add 5, then add 5. These become 0, x equals 32, which is that example there. All right, so on this example, so that would be a single step equation when we're adding or subtracting to get a variable by itself, because it has a term being added or subtracted to it. Now over here, we have a 2/3, and then it's a fraction, but when the variable is right next to it, it basically means multiplication. So now I have a 2/3 that is attached to the x through multiplication. We have to undo that, right? We have to make that, we can't just make this a 0. So now we're not going to add or subtract. We're going to use the multiply or divide factor, all right? So in this case, I need to make this 1. Here, I needed to make that term 0. Here, since it's attached to the x, I need to make that 1. So I can do that by multiplying by its reciprocal. So I multiply this by 3 over 2. But if I multiply this side by 3 over 2, I have to do the exact same operation over here. So that would be multiplying that by 3 over 2. So when we do that, we get 1x over here, because this times this becomes 1. And then 6 times 3 over 2 becomes 9. And this is using your calculator for that. Okay? There is another way to do this one. Here's the other way that I will show you. Because sometimes it's confusing to remember to multiply by the reciprocal. However, we talked earlier, if we multiply by the denominator, we get the numerator by itself. So I'm going to go back to a different example. Let's say I have 2x equals 8. So 2 times an unknown number equals 8. In this case, we know it would be 4, right? But to show my inverse operation, instead of multiplying by a half, I could multiply 2 times 1 over 2, right? Because 2 over 1 times that equals 1. But I can think of it like this. Just divide by that number, because those divide out. So that gives me my x, right? But what do I have to do on this side? I have to divide that by 2. 8 divided by 2 equals 4, all right? So when we have just that, it's easy to just divide by 2, both sides, get your answer, right? Over here, when I'm dealing with a fraction, you could multiply by the inverse, but we can also turn this into a 2-step problem. Let's say I multiply this by 3. The 3's divide out, leaving me with 2x. Now, if I multiply this side by 3, I also have to multiply this side by 3. So I have that. 3 times 6 is 18. And now I can turn it into a two-step. How do I make this a 1? Divide by 2. That's gone. Divide by 2. 18 divided by 2, x equals 9. All right. So that would be taking a fraction two-step. You can either multiply it right away by the inverse, or you can multiply by the denominator and then divide by the numerator. So kind of turning it into a two-step problem. All right, so we're going to do a couple examples here. I mean, these are all set up to be single step. Of course, unless you do the two-step one here, but I'm going to show you both. So over here, I have x minus 3 equals negative 8. So an unknown number, and I take away 3 equals a negative 8. On this side, I have my x. I want to get this 1x by itself, so I'm going to make this negative 3 become a 0 somehow by adding the opposite. So I'm going to add 3. But if I add 3 to this side, I have to add 3 to that side. So 1x minus 3 plus 3, so we're just combining like terms basically now. That's going to be x. And then on your calculator, just make sure you guys are getting the right information here. So I have a negative 8 plus 3. So negative 8 plus 3, that gives me a positive or a negative 5. So in this case, x equals negative 5. All right. Over here, I have another example. I have g, an unknown number, plus 7 equals 11. Well, you can kind of think of what that number might be. But to show our work using inverse operation, especially as the problems get harder, I'm going to make this term, positive 7, become 0. I'll do that by subtracting 7. Whatever I do on this side, I have to do on that side. So these become 0, leaving me with g equals 11 minus 7, which of course would be 4. So 4 is my answer. 4 plus 7 equals 11. I can substitute that back in. It makes it true. All right, over here, I can do one of two things, two steps or one step. I can multiply by the inverse of this. So I can multiply this by 4/3. And I know that's going to be 1. So I'm just going to write my 1x here. I don't need to put the 1, but I can. It doesn't matter. And then whatever I do on this side, I have to do on this side. So I'm going to multiply this by 4/3 as well. See how these are the same? So then you could just go to your trusty calculator again. 9 times 4/3. That gives us 12. So x equals 12. Again, doing this in two steps, if I have 3 over 4, x equals 9, then I could multiply this by 4, which would give me the 3 by itself. Multiply this by 4. So we would have to multiply this by 4, which would be 36. And then to undo this, we could divide by itself. 3 divided by 3 is 1. That gives me x. Divide this by 3. And 36 divided by 3 would be 12. So we get that same answer. All right, over here, we have negative 96 equals 4 times an unknown number. So again, if I make this 4, my goal is to make that 4 1. So I can just simply divide by 4. 4 divided by 4, anything divided by itself is 1. So 4 divided by 4 would just be c. And then to keep this balance, whatever I do on one side, I have to do on the other side. So I'm going to divide that by 4. So then I just go over to my trusty calculator. Let's type in negative 96. We divide that by 4. And we get negative 24. And we have solved for c. So if I put this back in to show my work, I can say, hey, if it works out, 4 times negative 24 should equal negative 96. 4 times negative 24, negative 96. Good. And you can do that for all of these. You can always substitute that back in like we worked on in our previous lessons and to check your answers. But once you get good at it, you trust your math, then you don't need to do that step.